I'm Randy Chung, CEO and a co-founder of SpaceFab.US. We started SpaceFab because we want to give everyone the ability to manufacture anything and everything they want to in space. Through asteroid mining and exponential manufacturing in space, the cost of manufacturing in space will approach zero, making it less expensive to manufacture objects in space than anywhere on Earth. We are implementing a step-by-step path to address this trillion-dollar market. Our first step is to build a profitable space telescope business by designing and operating the first commercial, multi-purpose space telescope in history. I started my career working on communication satellites at Hughes Aircraft. At Western Digital, I designed the world's first single-chip hard disk controller, the WD-1010, which turned Western Digital into a billion-dollar storage company. I've worked on image processing, CMOS imagers, and digital processing at Rockwell Semiconductor and Connexent. And I was the founder of a video streaming software company where I was the Chief Technology Officer for 15 years. At SpaceFab, I've come full circle back to aerospace and satellites.
Thank you, Randy. Hi, I'm Sean League, co-founder of SpaceFab. I have a degree in astrophysics and have been in the field of astronomy and optics my entire career. I have worked as a fiber optic engineer and have worked on anti-missile laser systems. I have also been VP and Director of Sales for several astronomical companies. In addition, I have started 5 companies, including US Telescopes Incorporated. And now I'm the Director of Spacecraft Development here at SpaceFab.
Each of our first-generation satellites will cost $2 million to build and launch, and should generate $10 million of revenue over its 4-year lifetime. We will provide an on-demand service for professional and amateur astronomers, as well as serving the ground observation market. We expect to reach profitability with our first satellite, and a corporate partner has offered us 2 launch slots free of charge. We plan to launch additional satellites every 12 to 18 months for civil, government, and educational markets. And we are already working on technologies for the deep space missions to mine asteroids and for exponential space manufacturing. Sean, please tell us about SpaceFab's first space telescope.
Sure. Thank you, Randy. I'm leading the design of our first space telescope. Here's an engineering model based on a 12U CubeSat standard. Using a CubeSat standard increases efficiency, decreases the cost of building the satellite, and decreases the launch cost. Our satellite uses many off-the-shelf parts, creating a considerable cost savings. But of course, we have some unique parts as well. One of these is the secondary mirror and extendable boom system. This allows us to stay in the economical 12U CubeSat form factor, but utilizes the large side of the spacecraft to have the maximum size telescope mirror, in this case about 8 or 9 inches in diameter. This is 4 times the area of our competitor's scope at the same launch cost. This extendable boom has to be solid and rigid once deployed, and one of our corporate partners who builds extendable booms for NASA and the European Space Agency will be designing and constructing the boom portion of the spacecraft. This will be the first generation telescope that we launch. The main telescope is a plane wave Dahl-Kirkham design, and our satellite is being designed for amateur and professional astronomers, as well as for ground observation customers. It will have color LRGB and narrowband filters for taking beautiful images, as well as research-grade filters for photometry and spectroscopy. The spacecraft contains 3 types of sensors: an 8-megapixel intensified EMCCD for UV, a 48-megapixel visible and near IR, and a 150-band hyper-spectral imager with 1.5-meter ground resolution. The space telescope will be available to the public at a minute or hourly rate, as well as a quick response on-demand rate for short-lived events such as supernovae. Important customers, such as researchers, will be able to schedule priority observations for specific times. As to the communications side of things on the spacecraft, the housekeeping and pointing instructions will be sent out via the Globalstar network. And that's what this antenna on the side is for here. But the bandwidth using this method is expensive and limited, so we'll be using a laser downlink to download the data back to Earth twice a day using optical ground stations, also using plane wave telescopes. Another corporate partner, FiberSat, is launching a large communication satellite in 2019, and they have given us a spot as a secondary payload on their SpaceX Falcon 9. So in mid-2019, we'll be in space and we'll start taking data.
We're raising our seed round of funding now, which will be used to complete our space telescope design and to build and test our pre-flight satellite. We have already filed one patent on our highly efficient ion engine accelerator, and we're writing more patents. We expect our space telescope business to be profitable soon after our first satellite is launched. Your investment will let us build our space telescope, the first step toward exponential manufacturing and asteroid mining, which will completely change what we can build in space, help us improve our life on Earth, and will let us explore and settle our solar system and beyond. Thank you for the opportunity to tell you about SpaceFab.
Yeah, thank you, and have a great day.